Hello everyone. Today we are going to talk about ionic compounds and solutions. I hope you will enjoy our lesson today. First, let's start the ionic compounds.
Leon has been swimming in the sea, in salt water. The salt found in the sea is the same substance we use in cooking, table salt. Table salt consists of two elements, sodium and chlorine. The chemical name of the compound is sodium chloride. Sodium and chlorine are both dangerous substances to come in contact with. Metallic sodium can cause corrosive burns on your skin, and if you inhale chlorine gas, you can damage your lungs. However, when sodium and chlorine have formed a chemical compound, sodium chloride, they're harmless. Why is that? It has to do with the atoms of the substances. The atoms in sodium are keen to get rid of electrons. This means that sodium easily reacts with other substances. It is reactive. When each atom lets one electron go, it becomes a sodium ion. Chlorine is reactive because its atoms want to pick up more electrons. A chlorine atom that gets one extra electron becomes a chloride ion. Sodium ions and chloride ions are happy with the number of electrons they have. So, in ionic form, neither sodium nor chlorine are reactive. The sodium ions that lost one electron are positive, and the chloride ions that picked up one electron are negative. Positive and negative charges attract. But as long as the salt is dissolved, as in this seawater, the ions move around without bonding to each other. Salt water is a sodium chloride solution. As the water evaporates, like it does here on Leon's arm, the ions will get closer to each other. So close that positive and negative ions will start attaching to each other. Here, one sodium ion is attached to one chloride ion. Does that satisfy them? Not at all. The positive charge of the sodium ions continues to attract negatively charged chloride ions from all directions. And the chloride ions attract more sodium ions from all directions. The ions attach in a repeating pattern, in a crystal lattice. Chemical compounds made up of ions are called ionic compounds. In a sodium chloride crystal, the ions are arranged like this, with alternating sodium and chloride ions. When the crystal has grown to contain some 100 quadrillion sodium ions and some 100 quadrillion chloride ions, it's large enough to be visible. A grain of salt. For each sodium ion there is one chloride ion. That means there is the same number of both. With chemical symbols, the substance is written like this, NaCl. This is the chemical formula for sodium chloride. In the chemical formula of an ionic compound, the positive ion is written first and the negative ion last. The plus and minus charges cancel each other out, so they are not included in the chemical formula. When we use the word salt, we usually mean table salt. However, in chemistry, salts are a whole group of substances. There are thousands of different salts. But since sodium chloride is the most common of the salts in the sea and in the kitchen, we usually just call it salt.
common salt is composed of two elements, sodium and chlorine. True. Which statement is correct? Sodium atoms want to get rid of one electron. Chlorine atoms want to pick up one electron. That's right. True or false? When an atom loses electron, it becomes positive charge. It's not negative. Which of these is the difference between sodium atoms and sodium ions? Sodium atoms easily react with other substances, which sodium ions don't. Sodium ions easily react with other substance. No. Sodium ions can combine with each other. No. And sodium atoms easily react with other substance, while the sodium ions don't. True or false? Salt dissolved in water consists of molecules of sodium chlorine. Salt dissolved in water consists of sodium and chloride ions. Why is sodium metal corrosive? Why? Because when the sodium atoms react with other substances, because they want to pick up one electron? No, because they want to get rid of electron to form positive charge. Which elements are present in table salt? Sodium and chlorine. Why is chlorine gas corrosive? Remember also the chlorine atoms easily react with other substances. Why? Because they want to gain one more electron and they are keen to pick up electron. What happens to salt dissolved in water? When the water begins to evaporate, what happens? The concentration of the salt increases until the solution is saturated. What is the chemical name for table salt? It's a very simple question. Sodium chloride. Which statements are true about sodium chloride dissolved in water? There is the same number of sodium ions as chlorine ions. This consists of sodium atoms and chlorine molecules. Sodium and chlorine are joined together 2 by 2. The ions move around freely in the water without being attached to each other. Which of these statements about salts are correct? There are thousands of different compounds that are salt. Remember, the salt can be neutral salt, basic salt, and acidic salt. And all salts contain positive and negative ions. Is how many sodium ions and chloride ions are required for a grain of salt to be visible without microscope? Is some hundred. Hydrogen atoms and chlorine atoms combine to form hydrogen chloride. Sodium ions and chloride ions are combined to form sodium chloride. This statement about the two substances are correct. Hydrogen chloride is not compact, no, it is compound. The hydrogen chloride can exist more than about 1,000th of a second since the atoms have no charge. Yes, hydrogen chloride form molecules with only one hydrogen atom and one chlorine atom to each. Hydrogen chloride is gas at room temperature because it consists of small molecules that don't attract each other. Which of these difference between a sodium chloride solution and sodium chloride in liquid form? There is no difference. No, there is. A sodium chloride solution consists of small solid grain of salt floats around. Liquid sodium doesn't contain any solids. The sodium chloride can dissolve in water at room temperature, but it doesn't melt until it's 100 of degrees Celsius. Homogeneous and heterogeneous mixture and solutions.
There are mixtures all around us. Some look very different to others. We usually divide mixtures into two groups. Mixtures where we can distinguish the different substances, and mixtures that look like one single substance. But where do we draw the line between the two categories? Let's perform an experiment. We have two beakers of water. We'll pour sand into the first one and mix some sugar into the second and stir them a bit. Let's start by looking at the beaker with sand in it. The grains of sand are clearly visible, and if we shine a torch through it, the sand particles are large enough to be lit up by the beam of light. When we stop stirring, most of the sand will settle to the bottom. It is not evenly distributed throughout the mixture. We call this a heterogeneous mixture. Compare this to the other beaker. The sugar water looks completely clear. There's no sign of the sugar that we mixed in. And when we shine a torch on the beaker, the light shines right through it. It is transparent. The sugar has dissolved into tiny particles. They are so small that they are impossible to see, even using a powerful microscope. They are separated down to the molecular level, and the sugar molecules are spread evenly throughout the mixture. We call this type of mixture a homogeneous mixture. Another common name for a homogeneous mixture is a solution. Solutions in water are always transparent, but they don't have to be colorless. Even though the particles are invisible, they can still give the solution a color. Solutions are not only in liquid form. Air is a gaseous solution, containing mostly nitrogen and oxygen. Solutions may also be solid. Brass is a solid solution of copper and zinc. Solutions of metals are called alloys. Since an alloy is a mixture, the metal atoms are only mixed with each other. They haven't reacted to form new compounds. It's easy to identify some mixtures as heterogeneous, but some are more difficult. Blood, for instance, looks like a solution. But when left for a while, it separates into a layer of blood cells and a layer of plasma. The blood cells are not dissolved in the plasma, and if you have a powerful microscope, you can see the individual blood cells. So what kind of mixture is milk? Milk is mostly water with some substances dissolved in it, but also a small amount of fat. The fat is present as tiny fat globules dispersed in the water. In fresh, unprocessed milk, some of the fat will rise to the top, forming a layer of cream. The milk you buy in the store is processed so it won't form different layers. This is done by splitting the fat droplets into smaller pieces in a process called homogenization. But still, even if these clumps of fat are small enough to remain suspended in the milk, each fat globule still contains thousands of fat molecules. So the fat isn't dissolved on the molecular level, which means that homogenized milk is still, in chemistry terms, a heterogeneous mixture. Psst, wipe your mouth, Michael.
Let's do some exercise. In heterogeneous mixture, the particles are distributed in heterogeneous. That's true. True. We usually divide mixture into two groups, homogeneous and heterogeneous mixture. True. Transparency is always colorless. No. All mixtures look the same. No. A solution is another word for homogeneous mixture. That's right. What do we call mixture that look like one single substance? We call the homogeneous mixtures. What type of mixture is alloy? The solid homogeneous mixture. What do we call mixture where we can distinguish the different substances? Heterogeneous mixture. Which mixtures are always transparent? Solution with water. What level to 1 particles need to be dissolved in order to call mixture a solution? Yes, molecular level. What is the other word for homogeneous mixture? Solution. Which of the following statements are true? They are solid solutions. The solution in water are always transparent. There are gaseous solutions. Which of the following are heterogeneous mixture? Still, sand, water, blood. And mist are heterogeneous mixture. For many water-soluble substances, there is a limit to how much of the substance can be dissolved. What is such a solution called? The maximum amount of solid in solvent are called saturated solution. Which of the following are homogeneous mixture? Air, sugar in water, and alloys are homogeneous mixture. Why do we say that milk is heterogeneous mixture? Yes, why? They are not dissolved down to molecular level because the milk contains the fats. Yes, you learn the solution. What is the solution? Also in solution, we have two parts, the solvent and the solid. You know what is the solvent? The largest amount of the solvent we call the solvent. and dissolved part, it is the solid. And if the solvent is water, this kind of solution we call aqueous solution, such as salty water. For example, in air, what is the solvent and solid for air? The largest part of the air is nitrogen. Remember the combination of the air, the 78% of air is nitrogen, and here the solvent is nitrogen in air. And for example, here what you see, your house, let's look, zoom in, it's alloy, is dental film. The amalgam also is solution. The steel solution here is alloys, one kind of alloy, brass, bronze, steel, carbon steel are solutions. Here are other examples for liquid solutions. Alkaline water, antifreeze, ethylene glycol, the salt in water, the soft drinks, gas in liquid, and air, the gas solution, and coins, alloys, dental filling, examples for solid solutions. And this solution, you know, the process of the solution, we call this solution dissolving of the solid in solvent.
Sodium chloride crystals are held together by attractive forces between the positively charged sodium and negatively charged chloride ions. When a crystal of sodium chloride is placed into water, the hydrogen ends of polar water molecules attract the negatively charged chloride ions and gradually surround them. Likewise, the oxygen ends of water molecules are attracted to and surround the positively charged sodium ions. The hydrated ions drift away into the solution, allowing new water molecules to surround newly exposed ions. Gradually, the entire crystal dissociates into solution.
Thank you for listening. Goodbye.